of the biggest challenges for mankind today is the depletion of natural resources. In a world where we need energy, water and food, resource efficiency is the backbone of economic growth and the very existence of humanity. Mikhail Lomonosov, a great Russian scientist of the 18th century, made a shrewd prediction when he said that Siberia would become Russia's driver of growth and strength. These days, Siberia has more than just oil, gas and gold to offer. It also has the intellectual potential to contribute to scientific and technological progress. Some of this potential is based at the National Polytechnic Research University in Tomsk, TPU, the oldest engineering and technology institution in Eastern Russia and a major research hub. The university is relentless on the lookout for new ideas and ways to use all types of natural resources efficiently. The university has 6 clusters studying resource efficiency. Planet Resources. This cluster focuses on water treatment, studying geology from space, and resource efficiency in mining. In the 21st century, most of the conventional oil and gas reserves have already been well explored. However, as output continues to increase, many old deposits will be exhausted in the near future.
Nowadays, most oil and gas deposits in conventional reservoirs are, unfortunately, running low, as they have entered the maturity stage.
This is why the world is looking ever more closely at tight oil and gas, hidden in low permeability rock and shale reserves. Some other promising prospects include gas hydrates.
Our lab has vast capabilities for in-depth oil and gas reservoir research.
The TPU Laboratory of Oil and Gas Geology has been working on assessment methods for potential oil deposits in unconventional reservoirs. Based on the geochemical testing of oils, their origin, composition and source rock maturity. The findings have improved assessment accuracy, making it possible to work out the best technical solutions for specific unconventional reservoirs. Russia has enormous supplies of fresh water, but water treatment and management is still very important. TPU's Water Institute seeks to develop and implement water conditioning and purification techniques.
The Giza TM water treatment system is designed for underground water purification and the supply of drinking water to the consumer.
The techniques are modeled after natural biological filtering. Durable absorbents are used to remove dangerous impurities. Unlike most purification systems, Giza TM, developed at TPU, does not use chlorine or related substances.
This enables us to retain the properties of high-quality activated live water and deliver it to the end consumer.
The Habitat Safety Cluster designs new generation CT systems and materials to be used in outer space, deep sea and the Arctic. In a bid to expand their habitat, humans constantly expose themselves to new risks and hazards.
Exploration of outer space requires new materials and equipment that can operate in extreme conditions.
The Department of Hydrogen Energy and Plasma Engineering is currently working on materials and coatings that can protect spacecraft from radiation and static electricity, a technology that relies on semiconductors and can considerably extend the orbit life for satellites. The Tomsk Polytechnic University brainchild is widely being put into practice by Russia's Federal Space Agency, Roscosmos.
Today, all GLONASS satellites are equipped with such optical reflectors.
Лаборатория пучково-плазменных технологий Института физики высоких технологий Томского
The Beam
Polytechnic
Plasma
University.
Technologies Lab at the TPU Institute of High Technology Physics focuses on the development and application of charged particle pulsed sources and plasma units in the production of coatings.
Exposure to pulsed ion beams, composite coatings and polycrystalline diamond films significantly expand the range of properties of materials currently being used in engineering, electronics and aviation.
This unit uses an electrical discharge to produce a plasma cloud.
Once the right amount of hydrocarbon chemicals has accumulated in a plasma cloud, they are then transformed into a thin polycrystalline diamond film, deposited on a variety of substrates. The system is unique in that the gas is activated by an abnormal discharge, allowing a high rate of diamond deposition, reaching up to 10 to 12 microns per hour. Durable materials play an essential role in building and maintaining safe environments for people and complex logistic processes. One important technology that ensures the accuracy of research in this field is computed tomography.
We are currently designing various types of CT scanners, with basic ones being ultrasound, X-ray, and thermal image tomographs.
CT imaging makes it possible to scan objects whatever their origin, size and configuration, measure their internal dimensions non-invasively, identify internal flaws and voids, and provide three-dimensional modeling of complex structures.
X-ray CT scanners are used to monitor and control sizable objects. In these tomographs, we employ our own unique innovations, cyclic electron accelerators that we call betatrons.
Betatron, a high-power X-ray radiation source, makes for a small-sized, as small as 0.3 of a millimeter, focal spot on the accelerator target, which helps to establish precision control over large objects. In this instance, TPU is studying the control momentum gyroscope, the attitude control device in a spacecraft.
The TPU Heat Control Lab is developing a non-destructive testing method for composite materials based on the so-called active thermored tomography technique.
To identify defects and failings in specific layers of an object, researchers analyze its dynamic thermal field. Presently, TPU is finalizing a portable thermal defectoscope, which will be used in aviation. The Open Laboratory for Non-Destructive Structure Analysis is working on improving the ultrasonic testing method to detect flaws in metals and polymers.
At the current stage, the main system developed as part of this research is the automated ultrasonic testing system. It allows us to test all kinds of complex structures and objects used across multiple industries, such as electric power, shipbuilding, car manufacturing, engine building, and space exploration.
Biomedical engineering. This cluster is working on biomedical technologies, electrophysiological medical systems, and nuclear biocompatible materials. Oncological diseases remain a key challenge for humanity. Radiopharmaceuticals have successfully been used across the globe to screen and treat cancer. At TPU, this is the domain of the Radiopharmacology Laboratory.
The Radiopharmacology Laboratory is developing medical products based on the short-lived radionuclide technetium-99.
TPU scientists have developed a unique method of generating short-lived technetium-99 and related medical diagnostic products by using the primary isotope, molybdenum-99, produced in the university's 6MW nuclear reactor through the irradiation of molybdenum. By contrast, this radioisotope is usually separated from uranium-235 fission products, leaving a large amount of radioactive waste.
Our technology is basically waste-free. which means that our product is much cleaner.
To separate technetium from radioactive molybdenum-99, TPU researchers have developed special machines called technetium generators. These are supplied to hospitals where radiologists extract technetium and administer injections to treat patients.
As a result, the patient receives a radiation dose that is 100 times smaller than during a regular X-ray scan, while the quality of the information obtained is much higher, as organ viability is tested at a cellular level.
The products that TPU develops are also widely used for the diagnosis of cardiovascular and other diseases. The Sustainable Energy Cluster focuses its research on hybrid modeling of power systems and resource-efficient generation. The lack of traditional fuel and power resources inevitably results in the transition to alternative energy sources.
Throughout the world, secondary energy resources such as solar panels, vortex generators, and small-scale hydropower plants produce 25 to 30% of electric energy.
Anything could be an alternative energy source. For instance, purified wastewater, a resource that each city or town produces in large quantities. Tomsk Polytechnic University has contributed to a unique project on the outskirts of Tomsk, the construction of a 1 megawatt hydroelectric power station. In the past, sewage disposal facilities used to dump thousands of cubic meters of grey water into the Tom River. Thanks to TPU's efforts, that same wastewater is now used for producing much-needed electric power. Cognitive systems and telecommunications. This cluster develops systems for communications, monitoring, and remote management. Scientific achievements are tremendously important in communications, but signal transmission still remains an issue in remote areas and under challenging conditions.
Одной из задач, входящей, в перечень проблем, которыми занимается
One of the projects our laboratory is working on is underwater digital communication systems.
называемые гидроакустические модели.
Our second project is designing an onboard data measurement system.
TPU's Telecommunications, Instruments and Marine Geology Laboratory builds hardware and software for new generation autonomous submersible robots. They can be used for taking the robots to greater depths and transmitting more information. They also offer the possibility of simultaneously managing dozens of submersibles. Robots are equipped with sonar sensors, video surveillance and navigation systems, as well as sensors that enable the collection of data on underwater objects, exploration of the continental shelf, and inspection of communication lines and pipelines running along the seabed.
Почему Томский политехнический университет избрал своей, скажем так, религией ресурсоэффективность? По ряду причин.
Why did Tomsk Polytechnic University commit to studying resource efficiency so religiously? Well, Russia is an energy-intensive country. We spend 2 or 3 times more on materials, power, and human resources per unit of production compared to Western countries. In order to close this gap, it's important not only to develop new technologies, but also to educate people, because the culture of resource saving is something that has to be learned through lifelong education.
TPU recognizes the social and ethical aspects of science, technology, research and development. The university views scientific progress in the context of sustainable development for society in general, which implies that each of us contributes to progress by gaining knowledge. TPU is one of Russia's top universities. As it rapidly develops and builds its potential, TPU intends to become one of the world's leading academic centers, and we're confident that we will be able to reach our goal by focusing on resource efficiency. Tomsk Polytechnic University.